Okay. Just one second, please. All right. So the first thing about today's lesson is just a quick recap. Okay, I'm going to write down the equations right in front of you so that we can have that in our head. So x minus h whole squared plus y minus k whole squared equals to r squared. So if this is the format of the equation of circle you have, then the center is going to be h and then k. These are the coordinates for the center of the circle, and then root of r squared, that is going to give you the radius of the circle. And if the square equation is x squared plus y squared plus 2 fx plus 2 gy plus c equals to 0, then the coordinates for the center of the circle are going to be minus f and then minus j. And then if you want to work out the radius, that is going to be f squared plus j squared minus c, and then the whole root of it. So this is how you can work out the center and the radius from both formats. Okay, now before we proceed further, we will be requiring a prior knowledge, which you already have, but I'm just going to quickly go through it. So for example, if I give you 2 points, that's the first thing which we should know before today's lesson, that if I give you 2 points, as in, let's just say this is 1 point A, and we've got another point B, and if I want you to write down the equation of the perpendicular bisector of AB. So the first of all, the perpendicular bisector is going to be the line passing from the midpoint of A and B. So that's not exactly mid, so let me just pull it down towards the left. Yeah, and it would be at 90 degree to A and B. So first of all, we'll be needing the gradient of A and B, which you will be calculating by the formula y2 minus y1 over x2 minus x1. Once you have the gradient of AB, then you will be applying this concept that m1 times m2 equals to -1 for the perpendicular lines. By applying this, you can have the gradient of the line perpendicular to it. So we have the gradient for this yellow line. Now all we need is a point through which this yellow line is passing. We know this yellow line is passing through the midpoint of A and B, and we can work out the coordinates for the midpoint of A and B by following this concept like x1 plus x2 over 2, and then y1 plus y2 over 2. So from here we are going to have the midpoint of A and B. Once we have the midpoint and the gradient of the yellow line, we can apply y minus y1 equals m times x minus x1 in order to work out the equation of the perpendicular bisector of A and B. Got it?
Yes, sir.
Okay. Now, another thing which we also studied in our previous classes about a chord. Chord is a line inside a straight line inside a circle which starts off from the circumference and end at the circumference. But unlike diameter, it does not pass through the center. It can be anywhere in the circle. And if you draw multiple chords in a circle, it's not necessary that all of them they are going to have same length. They can definitely have different lengths. Okay? So this is the definition of chord. Just a quick recall to what a chord is. Got it? Now, the important concept which I want to tell you over here is whenever you draw, that's the important concept which you should know here. So, a perpendicular bisector of a chord always passes through the center of a circle. So if you draw a perfect perpendicular bisector of let's just say this chord, it will definitely pass through the center of the circle. So that's the concept here. Okay,
Yes,
got
sir.
it? So let's just
Yes.
use this concept and see what we can do. Uh, how we can work out. So, for example, if the examiner asks you to gives you the points on the circumference of the circle, so let me just draw a circle here. So I'll be using the same concept which I've just discussed up there, and we'll try to write down, see how we can work out the equation of the circle. So let's just say we've got a point A whose coordinates are 0 and 17. And let's just say we've got another point on the circle, and let's just say it's over here. And let's just say it's 8 and 13. Let's just call it as a point B. And then there is a point C as well, which is also on the circumference. And let's say its coordinates are -10 and 7. So these are the points on the circumference of the circle. So now the examiner wants you to find the equation of the circle. So the only information examiner has given us that there's a point A, B, and C, and with the coordinates definitely. And he is asking you to write down the equation of the circle. So we need to write down the equation of circle. So uh, just to know that in order to write down the equation of the circle, we always need two things. One, the coordinates for the center, and then the radius of the circle. So if I've got these two things, I can easily write down the equation of the circle. Okay? So let's see how we can work out these two things from the information which we already have. Okay, so if I draw, I know that if I draw a perpendicular bisector of AB, so here's just a quick run through of what I'm going to do here next. So if I draw a perpendicular bisector of AB, so let's just say this is the perpendicular bisector of A and B. Got it? So I know for sure by using this property that it will always pass through the center of the circle. So let's just assume that the center of the circle is over here. Okay? All right, exactly in the same way, if I draw a perpendicular bisector of B and C as well, I know that for sure that this perpendicular bisector of B and C will also pass through the center of the circle. Okay, so let's just name the two perpendicular bisectors as L1 and L2. So if I've got the equation of L1 and L2, how can I work out the center of the circle? Can you recall?
We can find the midpoints of a like the chords, and using the midpoints, then we can find like the M1, M2.
Yeah, fine. So that is going to give us the equation. So I've got, let's just say I've already worked out the two equations. I've got the equation of L1 and I also have the equation of L2. How can I find the center of the circle by using these two equations?
Uh, the you have to figure out where they intersect each other. That is the center of the circle.
Yeah, and how can I find the intersection points of the two lines?
You equate them. L1
Nice.
equals to.
We solve them simultaneously. So basically, we equate them or we solve them simultaneously. That's it. So by doing that, I'm going to have the center of the circle. So I will have the coordinates for the center. So if I equate or solve these two equations simultaneously, I will have the center of the circle. Now, once you have the center of the circle, so let's just say we've already figured out the center of the circle. Now, can you tell me how can I work out the radius of the circle?
Um,
So I have,
um,
yeah, just think a little bit more. I have the coordinates for the center of the circle. I need to know the length of a line starting from the center to any point on the circumference, which is known as the radius. So I've got the coordinates for the center.
Then we can like make an equation using the center and then one of like the points A, B, or C.
Yeah, we can, yes, we can apply the distance formula on either of these 3 points and have the radius. So once I have the center and radius, boom, you have the equation of the circle. Nice. Is the plan clear?
Yes, sir.
Great. So let's just find out the equation for the perpendicular bisector of AB. Okay. So first step is
Yes,
going
sir.
to be equation for perpendicular bisector of AB. Okay, so A is the point 0, 7. Oh, sorry, 0 and 17, and B is the point 8, 13. Now let's just find out the gradient of this one. So I'm going to do the gradient of AB. That would be 13 take away 17 over 8 take away 0. So that will leave us with -4 over 8, which is going to be -1 over 2. So this is the gradient of A and B, the chord AB. Okay. Now, from here, I
Yes, sir.
know the gradient of the line L times the gradient of the chord AB. This should be equals to -1 because I'm finding the equation of the perpendicular bisector. So the gradient of this is going to be the negative reciprocal of whatever the gradient of AB is. Okay, so the gradient of L times -1 over 2 equals -1. So the gradient of L is going to be 2. Clear?
Yes, sir.
All right, so now I've got the gradient of the line L1. Now I need to know the point it is passing through so that I can work out the equation for this one. So for that, I need the midpoint of A and B. So let's just work out the midpoint of A and B. So midpoint would be 4. Let me just do the calculation properly. So 0 plus 8 over 2, and then 17 plus 13 over 2. So that would leave you with 4 and 15, I believe. Got it? Yeah, 4 and
Yes.
15. So that's the midpoint. Now, let's just work out the equation. So, equation for L1 would be y minus y1 equals m times x minus x1. So y is equal to 2x minus 8 plus 15, and y equals to 2x plus 7. So that is the equation for L1. Got it?
Yes, sir.
Okay, now let me just quickly tell you how you can directly reach this particular step over here instead of going through all these. So you know that it's the negative reciprocal. The perpendicular of a perpendicular line is the negative reciprocal of the other one. So instead of working out y2 minus y1 over x2 minus x1, you can do it directly by doing negative x2 minus x1 over y2 minus y1, because this is negative reciprocal of this. So it will give you directly this answer here. Okay?
Yes, sir.
I didn't use this formula earlier so that I wanted you to know what we're going through so that you can work this out later on whenever you're doing in the question in the exam. Okay?
Yes, sir.
All right, so Exactly the same way we need to work out the equation of L2. Now over here, I'll be using this formula. Okay, so equation of L2. All right, the coordinates for B are 8 and 13, whereas for C, they are -10 and 7. All right, so gradient of perpendicular bisector of BC will be equals to negative of x2 minus x1 over y2 minus y1. If this is confusing to you, you can stick to the one the normal method which you've been doing earlier, this one. Okay.
Yes.
All right, so that is going to leave you with negative, okay, -18 over -6, and this is going to give you -3 as an answer. Okay,
Yes, sir.
so that's the gradient. Now we need the midpoint of B and C. Midpoint of B and C. So that would be 8 minus 10 is -2. -2 over 2 is -1. 13 plus 7 is 20. And then half of 20 is 10. So that's the midpoint for the B and C. Now, equation of L2 would be y minus y1 equals m times x minus x1. Okay?
Yes, sir.
And this will leave you with -3x plus, and then plus minus is -3 plus 10, which is actually -3x plus 7. So that is our second equation. So I've got the two equations here, this one and this one. I know both of these two lines, they are passing through the center. So if both of these they are passing through the center, means they are intersecting at the center of the circle. So if I want to know the intersection, the coordinates for the intersection points, in other words, the coordinates of the center, I wouldn't have to solve both of these simultaneously. Okay?
Yes, sir.
So solve equation 1 and equation 2 simultaneously. So the first one was y equals 2x plus 7, and the other one is y equals -3x plus 7. So from here, I can equate both of them. 2x plus 7 equals -3x plus 7. And from here, 7 and 7 cancels out with each other. So 2x plus 3x equals 0, 5x equals to 0, x is equals to 0. All right, so I've got the x coordinate of the intersection point. Now I need to work out the y coordinate. So for x equals to 0 in equation 1, you can substitute in any of the equations. So I'm going to substitute it in equation 1. So y is going to be equals to 7. So if y, okay, now therefore, the center of circle is at 0, 7. So we have the coordinates for the center of the circle as 0 and 7. Now we need to work out the radius. Okay, so we have the coordinates of this one, which is 0, 7. Now we can apply distance formula on this one. and either of these 3 points. So let's just go for point A because this one looks very easy to me. Okay.
Yes, sir.
Okay, so 0, 7 and then 0, 17. So A is 0, 17 and the center is 0, 7. So let's just apply the distance formula on center and A. So OC, let's just call it as, sorry, OA, or which is the radius. That would be equals to, okay, y2 minus y1, and then the whole square of it, plus x2 minus x1, and then the whole square of it. Okay, so you can write this down as uh, 10 squared, and then the root of it, which will leave you with just 10. So the radius is 10. Now, once I have the center and the radius, now I can easily write down the equation of the circle. So x minus h is 0, y minus k is 7, and r is 10, which is going to leave you with x squared plus y minus 7 whole squared equals to 100. Got it?
Yes, sir.
And just in case if the examiner asks you to give the equation in the format x squared plus y squared plus 2fx plus 2gy plus c equals to 0. Now the question is, can you write down the equation directly into this format? Having said that, you have the center and the radius. The best way is to expand this. Okay, you will always obtain the equation in this format, and then you will expand it to write it down in this format. Okay,
Yes, sir.
so you'll be doing x squared plus, then you expand y minus 7 whole squared, which is going to give you y squared minus 14y plus 49 minus 100 equals to 0. At the same time, I brought 100 on the left hand side as well. So x squared plus y squared minus 14y and then minus 51 equals to 0. So if you want to put the equation in this format, this is how you'd be doing. Okay,
Yes.
is this clear?
Yes. Sir, for that, what would the value of G be? Like
For
14
this
divided
one?
by 2? Yes.
Yeah, so you'd be doing basically, if you want to know the value of G, you'll be doing, because this one has to be positive. Okay, so what you can do is you can always compare 2gy equals to minus 14y. So y cancels out with y, and g would be equals to negative 14 over 2, which is going to give you negative 7. Okay?
Yes, sir.
All right. Okay, so this was one concept. Now let's just move on to the another one where we'll be talking about the angle inside the semicircle. For that, the important concept. Okay, the key concept for the previous thing was that whenever you draw a perpendicular bisector of a chord, it always passes through the center of the circle. Clear? Okay,
Yes, sir.
about the angles of the angles inside the circle or inside the semicircle. Before I jump to that, let me just tell you a very important thing here, that no matter what type of triangle you have, no matter what type of triangle you have, it is always possible to draw a unique circle which passes through all the three vertices of that triangle. So for example, you have this triangle here. Okay, apparently it looks like we won't be able to draw a circle through it, but technically, if I consider that this as a chord of a circle and this as another chord of the circle, if I draw two perpendicular bisector, this would be the center and I would be able to draw a perfect circle through all the three vertices of a circle. Okay, so it is
Yes.
always possible to draw a unique circle through all the three vertices of a triangle. Got it? And that is known as a circumcircle of a triangle. Okay,
Yes, sir.
so the so it is always possible to obtain a circumcircle, which in short is no matter where you have the 3 points and you have the triangle, you can always draw a perfect circle through all those 3 points. I'm sorry, this one looks funny and it doesn't even look like a circle, but it is always possible. Okay, it's just a rough diagram. So, got it?
Yes, sir.
So this is basically known as a circumcircle. So by using this concept, and if you recall from your IGCSE that you studied a property of semi angle property of a semicircle, or your semicircle angle property, it was that from the diameter. So let's just say this is the diameter of the circle. So whenever you see an angle being subtended anywhere on the circumference from a diameter, or you can call it as from a semicircle, that angle is always of a 90-degree angle, remember?
Yes, sir.
So this was a property we studied in IGCSE. So now if I combine the fact about the circumcircle, that we can draw a perfect unique circle through any 3 points of a triangle. So no matter what type of a triangle it is, you will always be able to draw a perfect circle through the vertices of a triangle. Okay, and if I combine this property with that as well. Now, let's just say if I tell you I've got a triangle, so let's just say I've got 3 points, A, B, and C. If I tell you that I can obtain a triangle from these 3 points. And if I can obtain a triangle from these 3 points, then you should be able to draw a perfect circle through these 3 points by using a property of circumcircle. Now, if somehow I can prove that the three coordinates make a right angled triangle, a right angled triangle, how will I be able to prove that? That if the 3 points combined together, they make a right angled triangle. You've studied this in your IGCSE, just try recalling it. If I have the three lengths of a triangle, how can I prove that a given triangle is a right angled triangle? Hmm?
Um, uh, like we can apply the Pythagoras theorem.
Perfect. So first of all I have to do is I'll be finding three lengths here by using the distance formula AB, BC, and AC. Once I have the three lengths, I will apply a Pythagoras theorem on it. If it fits on the Pythagoras theorem, then it means then the longest one out of these three is a hypotenuse. So for example, let's just say A and C, that turn out to be a hypotenuse. Even by using that concept, I can easily work out the equation of the circle. So once I know that A and C, a line connecting A and C is the hypotenuse, so if I work out the midpoint of A and C, it is going to give me the coordinates for the center of the circle. So that from here I can get the center. And if I half the length of the hypotenuse, that is going to give me the radius. and then boom, radius is there, and the coordinates for the center of the circle is there. So I can easily work out the equation of the circle. Got it?
Yes, sir.
So let's just say I give you 3 points as 1, 9, and B is 8, 8, and C is 7, 1. An examiner asks you to write down the equation of the circle which is passing through these three. Okay? All right. First of all, I need to know. Now, one way of doing is by using the concept we did earlier up here. So if I consider that these as chords, find out the perpendicular bisectors, find out the intersections, and then you have the center. And then you find out a distance from center to either of these 3 points. So that one we just did. Now I'm going to apply this property here. So let's just find out AB. So the distance AB is going to be 8 minus 9 whole square plus 8 minus 1 whole squared. So if I work this out, that is going to give me root of 1 squared plus 7 squared. And that is, I'll leave it in index form, sorry, third form, which is 5 root of 2. Okay? And let's just
Yes,
work
sir.
out BC. BC is going to be 1 minus 8 whole squared plus 7 minus 8 whole squared. Okay, so that will leave you with 7 squared plus 1 squared, which is going to be same as before, is 5 root 2. Now let's just work out AC. Now AC is going to be root of 1 minus 9 whole squared plus 7 minus 1 whole squared, which is going to be 8 squared plus 6 squared. And that is actually equals to 10. If you recall, 5 root of 2 was giving me the decimal value of 7.07. So basically, AC is the longest of all the three sides. So let's just see if we can satisfy the Pythagoras theorem and prove that these three coordinates make a right angle triangle. Okay, so according to the Pythagoras theorem, a hypotenuse squared should be equals to the sum of the square of the other two sides. So I'm going to do 10 squared equals 5 root 2 squared plus 5 root 2 squared. So 10 squared is 100, and that is going to give you 5 squared is 25, and the root 2 squared is just 2. The same goes over here. So 50 plus 50, that is 100. So we see that it fits in the Pythagoras theorem perfectly. Therefore, ABC is a right angle triangle. So once I know that it's a right angle triangle, then which one of these is going to be the diameter of the circle?
The longest length.
Yes, the longest one. AC, the hypotenuse is actually the diameter here now. So basically, therefore, AC is diameter. So if that, this implies that the radius is going to be half of 10, which is 5 units, isn't it?
Yes, sir.
So from here, we've got obtained the radius. Now let's just work out the coordinates for the center. So for that, all we have to do is find out the midpoint of A and C together. Okay? So A
Yes,
was
sir.
1, 9, and C was 7, 1. So if I work out the midpoints of A and C, that would be 1 plus 7 is 8, and half of 8 is 4. Then 9 plus 1 is 10, and half of 10 is 2. Sorry, 5. So that's the center of the circle now here. Now let's just write down the equation. So we know x minus h whole squared plus y minus k whole squared equals to r squared. X minus h is 4 plus y minus k is 5, and r is 5. So which leaves you with x minus 4 whole squared plus y minus 5 whole squared equals 25. Got it?
Yes, sir.
Easy?
Yes.
All right, now last concept about that. Again, I'll be using one of the properties which we've studied in IGCSE. If you recall, a circle and a tangent to a circle at any particular point, and then a radius having a common point on the circle as that of a tangent, then the property was that tangent and radius, they would be perpendicular to each other. Okay, got
Yes.
it? So this property we've already studied in IGCSE. Now we can use this fact in order to find out the equation of tangent to a circle at a given point. How would we find out the equation of tangent? So for any equation of straight line, what do we need? We need the gradient. How can we work out the gradient? If I know the gradient of the radius, so if I know these two coordinates here, if I know the gradient for this one, then the negative reciprocal of this one is going to give me the gradient of the tangent line. So boom. And the tangent is also passing through the same point as that of one of the point on the circle. So if I plug that in, so y minus y1 equals to m times x minus x1. Boom. I will have the equation of the tangent. Got it? Easy?
Yes, sir.
So let me just attempt one of the questions. So examiner is saying that we have the circle x minus 5 whole squared plus y minus 2 whole squared equals to 25. So let's just say this is one of the circle. And then there is the point P on the circle whose coordinates are 2 and 6. Okay, so it lies on the circle. And he asks you to find the equation for the tangent to the circle at point P. As I stated, how would we find out the equation of tangent at a given point? So I need the coordinates of this. I have it. I need the coordinates for the center. I can extract it from the equation. Once I have this, I'll work out the gradient of this. From there, I'll jump to the negative reciprocal. That is going to give me the gradient for this one, for the required equation. Okay. Now I need the point from which the tangent is passing through to plug it in here. That point is point P. The tangent is also passing through the point P. Got it? All right, so
Yes, sir.
let's just write down the coordinates for the center. That is going to be 5 and 2. Got it?
Yes, sir.
Okay, now I'm directly going to write down the gradient for this one, which was negative. So the gradient of tangent, it would be negative, and then x2 minus x1. So x2 minus x1, this is x2, this is x1, over y2 minus y1, which is going to be 2 minus 6. So that leaves us with negative 3 over negative 4, which is positive 3 over 4. So that is the value of m for this tangent. Okay? Now,
Yes.
y minus y1 equals m times x minus x1. We know that tangent is passing through the center, oh, sorry, touching the center at point P. So these are the coordinates here. So the tangent is passing through the point P as well. So y minus y1 equals m times x minus x1. So all I have to do is simplify this. 3 over 4x minus 3 over 2. 3 over 4 times 2 is going to be 3 over 2, and then plus 6. So y equals 3 over 4x, and this is going to give you minus 9 over 2. Minus 3 by 2 plus 6 will leave you with negative 9 by 2. If you can work this out on your calculator, you should be left with minus 9 over 2. And here is the equation of the tangent touching the circle at point P. Got it?
Yes.
Okay, that this is all about what you can do with this. These are all the concepts. So we started off with the main equation of circle, then we went to like if we draw the perpendicular bisector of any chord, it passes through the center. We use that concept to work out the equation of two perpendicular bisectors of two different chords, and worked out the intersection point by solving them simultaneously. So from there we got the center. And once we have the center, we can work out the radius by calculating the distance from center to any of the points on the center. So that is going to give us the on the circle. So that would give us the radius, and we can work out the circle. And then we studied another concept of circumcircle, that we can always draw a unique circle from the three vertices of a triangle, which is known as a circumcircle. But if it happens in such a way that if the that particular triangle from which you're drawing a circle is a right angle triangle, which then the hypotenuse will always be the diameter of that particular circle. From there, you can work out the radius and then the midpoints to get the center of the circle and write down the equation. This is we studied about the tangent at one particular point, how to write down the equation of tangent to a circle. Now, one last thing uh, about a line which could be a tangent. Okay, now let me just draw three different lines here. This is line A, which is it's a white color line. This is line B, which is a yellow line. And then I've got a green line. Let's just call it as C. Now, what can you say about the three lines here? Hmm? So if I want to ask you what is line A, B, and C, like how would you explain it to me?
Um, line A is the tangent to the circle.
Nice.
Line B is the chord.
No, it's not a chord. Chord starts from circumference, it ends at circumference. That's it. So if you
Um,
see that, it's also outside the circle.
okay. And C is just
Okay.
a line.
Yeah, it's just a line. So how would you differentiate it between from A?
Um, it does not touch the circle at any point. Oh, line B, it touches the circle at 2 points.
Nice. It cuts the circle at 2 points, whereas A It only touches the circle at 1 point. What about C?
It does not touch the circle at any point.
Nice. So if you want to know, okay, now if you try recalling quadratics, so for example, I have this quadratic curve. If you try recalling quadratics from pure maths 1, and then I have a line, let's just say this line. If I solve these the equations of the two curves here simultaneously, the discriminant b squared minus 4ac will be greater than 0 if it cuts the curve at two different points. Remember?
Yes.
The discriminant, which b squared minus 4ac would be exactly equals to 0 if it touches the curve at 1 point. And the discriminant would be b squared minus 4ac would be less than 0 if it is not touching the circle at any point. Okay, so we can apply the same concept here. So if I have the equation of the line and I also have the equation of the circle, if I solve them simultaneously, if I solve them simultaneously, and if I end up with just one repeated solution. So for example, I solve the two equations simultaneously and I get two repeated roots as x equals to 1 and x equals to 1. What does that show? That discriminant, when do we get this type of situation? When we have two repeated roots means we have the discriminant as 0, means the tangent, that particular line which we just solved with the equation of circle is actually tangent to the circle. Okay, so if the examiner asks you to prove that one particular line is tangent to the circle, all you have to do is solve them simultaneously and you should end up with just one, like two repeated solutions. That's it. Okay,
Yes, sir.
and if you in like if you're trying to prove that if it is a tangent or not, and at the end if you get two distinct solutions, or you can work that out, instead of solving it completely you can directly apply the discriminant test. If the b squared minus 4ac is greater than 0 means you're going to have two distinct solutions, means it is going to cut the circle at two different points. And if the discriminant turns out to be negative, it means it's not even near the circle. It's not cutting the circle, it's not touching the circle at any point. Okay?
Yes, sir.
So let me just draw a summary here. So you have the equation of circle, you have the equation of line, you solve them simultaneously, or equate them. Instead of jumping towards the solution, before you jump to the solution, you will always end up with some sort of a quadratic equation. Okay, then you apply a discriminant test on it, b squared minus 4ac. If now from here we will have three possible outputs. The discriminant is less than 0, discriminant is equals to 0, or discriminant is greater than 0. If the discriminant is less than 0, line and circle, they do not cross or touch at any point. Okay, if the discriminant is 0, then the line is tangent to circle, means it is just touching the circle at 1 point. And if the discriminant is greater than 0, then the line is crossing the circle at 2 points. Now, this is how you can prove it. But if the examiner asks you to work out the coordinates of the point where the line is tangent, or work out the coordinates of the points where the line is actually crossing the circle, then all you have to do is solve this equation. That's it. By solving this, you will have the x coordinates. Once you have the x, in order to work out y, you can substitute the value of x in either of these two equations to work out the value of y's. Okay?
Yes, sir.
It sounds very complex, but it's very simple. Like it's nothing, you've already worked it out. So you have the equation of circle, you have the equation of line. If you solve them simultaneously, before you jump to the final solution, you will always end up by mixing up the two equations. You will, if you, upon simplification, you will have a proper quadratic equation. So if the question is to prove, then all you have to do is apply the discriminant test, which is b squared minus 4ac. If it's less than 0, then the line and circle, they do not cross or touch. If it's 0, means the line is tangent to the circle. And if it is greater than 0, then it means that the line is crossing the circle at 2 points. Okay, now this is what you're going to do if the question is just to prove if it is a tangent or not. So if it's tangent, the discriminant should be 0. Then from there you will conclude that's it. You don't need to solve it further. But in some cases, examiner might ask you to work out the coordinates of the point where the line is tangent to the circle. Then you need to solve this equation. This is going to give you the value of x. Okay, so for example, it is tangent at point P. You work out the value of x as 1. All you have to do is work out the value of y. Put this x equals to 1 in either of these two equations in order to work out the y for that particular coordinate. Same goes for this one. You will have two distinct solutions, like two separate solutions. And for both values of x, you need to work out the value of y separately. Got it?
Yes, sir.
I would like you to do the question related to this and send it to me. I'm going to send you a question. After the class, I would like you to attempt the question and send it to me. Okay?
Okay, sir.
I'm going to look for a question and see if I can find a good question. How can I find it? Just bear with me for a minute. In the meanwhile, if you have any question to ask.
No, sir, no questions.
No questions? Easy?
Yes, sir.
Okay, so you can always go through the recording. I would suggest go through the recording.